We are very fortunate to be able to welcome Kathy Lueders, NASA's new Associate Administrator for the Human Exploration and Operations Mission Directorate, to the ISS R&D conference this year for the first time. In June of this year, Kathy Lueders was selected to lead NASA's Human Spaceflight Office. Kathy began her NASA career in 1992 at White Sands Test Facility in New Mexico, where she was the Shuttle Orbital Maneuvering System and Reaction Control Systems Depot Manager. She later moved to the International Space Station program and served as Transportation Integration Manager, where she led commercial cargo resupply services to the space station. Kathy also was responsible for NASA oversight of international partner spacecraft visiting the space station, including the European Space Agency's Automated Transfer Vehicle, the Japan Aerospace Exploration Agency's H-2 Transfer Vehicle, and the Russian Space Agency Roscosmos Soyuz and Progress spacecraft. Kathy went to Kennedy Space Center as Acting Commercial Crew Program Manager in 2013. Since 2014, Kathy has directed NASA's efforts to send astronauts to space on private spacecraft, which culminated in the successful launch of Demo 2 with astronauts Robert Behnken and Douglas Hurley from the Kennedy Space Center in Florida on May 30th, and more importantly, their successful return to the Gulf of Mexico on August 2nd. Kathy?
Can you hear me?
I can hear you.
Yeah, it's Thomas. I just learned from my friend Kathy that she has computer problems and she's trying to get back. We could perhaps reorder. And I go after an introduction, she comes back. I have her own text here. That's why I know, sir. Excellent.
That works fine. We are flexible. So I'll add to Kathy's introduction. I have the great good fortune today of also being able to introduce Dr. Zurbuchen. Growing up in Switzerland, Dr. Zurbuchen was a keen observer of the natural world from an early age. His curiosity led him to pursue degrees in physics, and he has served on and led innovative scientific teams that have helped enlarge our perspective of the solar system and the universe. He was a professor of space science and aerospace engineering at the University of Michigan, Ann Arbor, and was the founding director of University of Michigan's Center for Entrepreneurship at the College of Engineering. On a daily basis, Dr. Zurbuchen works to ensure that NASA's science missions build partnerships across disciplines and within industry and other nations to generate new questions and help advance the frontiers of knowledge and exploration. He brings a wealth of scientific research, engineering experience, and hands-on knowledge to NASA's world-class team of scientists and engineers. Dr. Z sets the NASA science strategy and inspires teams to carry it out. Dr. Zurbuchen has authored or co-authored more than 200 articles in peer-reviewed journals in solar and heliospheric phenomena. His honors include multiple NASA Ground Achievement Awards, induction as a member of the International Academy of Astronautics, a NASA Outstanding Leadership Medal, and the 2018 Heinrich Granecker Prize, the leading science-related recognition from the University of Bern. Thank you, Dr. Zurbuchen.
All right. Look, I'm so excited to be here today, and I'm hoping that somebody can gear up the slides. Can you tell me if they're there? There's slide one. Can you hear it? Can you see it? Just want to check quickly.
Yes, slide one is up.
All right, wonderful. Look, I'm really excited to be here. You should know this is my first presentation to this audience since biological and physical sciences was integrated into the Science Mission Directorate. And I really look forward to getting to know both the science that this important directorate is doing, but also really getting to know the community. And so I look forward to the questions and answers. And also I want to commit to you that, of course, just like with every other discipline, I will spend personal time with this community. So what I thought I'll do right now is give you kind of an overview of how we think about science and its applications, and also how, in fact, we, in fact, how we focus on some of the highlights. And what I'm going to do is focus on very few kind of biological and physical sciences topics, and just kind of tell you the story of exploration and application that is so important to this field. And so with the next slide, I'm going to focus on the motivations of the science that we do. So slide 2, please. The motivations that we have to do science are threefold, and they're really important and at the heart of everything we do. First of all, it's discover the secrets of the universe. We live and think in a space that is defined by what we know about the universe. Learning about the universe teaches us about ourselves, and discovering the secrets of the universe is therefore one of the most important things we could be doing as humans as we think about really how we live, where we live in the whole universe, but also how it all hangs together. Discovering the secrets of the universe, if you've done it, you know how it feels important, how it feels special to see these amazing rules that are out there in the universe that remain to be discovered. We've learned a lot about the universe, but most of the things of the universe, frankly, we still don't know, including one of the topics that we generally refer to as astrobiology, which is search for life elsewhere. The questions in astrobiology have been with us for millennia. Philosophers have written about in ancient texts. They have been with us. But what's really has happened in the last decades is that we started to discover pieces to that puzzle with the tools of science, frankly, in a way and at a speed that nobody had predicted, whether it's in exoplanets, whether it's finding worlds which carry the promise of life or ancient life, such as Mars, ocean worlds, but also the mechanisms that we discover from in biology that are really focused on life elsewhere. So astrobiology is one of the top priorities for us because of its tremendous promise, and also because of the excitement that we have. Having biological and physical science as part of that enriches the tool set to really tackle together that interdisciplinary field. Protecting and improving life on Earth and in space is all about one of the elements that we are excited about in science, which is whenever our research has actual applications, we think it's a double win, whether that's in earth science, and I really appreciate the moment of silence we took at the beginning, especially focused on the severe weather in Texas, Louisiana, and elsewhere. The view from space have affected our lives, has protected life. We think of the historic reports of the hurricanes at Galveston, which was so devastating, where we didn't have those views. And we see the situation today. Yes, the storms are there. Yes, we see them coming, but we can move people out of the way. Similar things happen about planetary defense, and also really about the very important work that biological and physical sciences is doing, protecting life, not just on Earth, but also the life in space that we treasure, our astronauts and their colleagues from other countries that are out there and are really expanding the space in which we work and live in. The next slide is showing how we do this work. And each one of these disciplines in colors there, of course, at the bottom left, there are earth science. You see heliophysics, you see astrophysics, and you see planetary science, and you see now the biological and physical science. You see these assets, not all of the assets are there from a specific size up. And you see the important work that happens on the space station that is from many disciplines actually shown there. By the way, in boldface are the instruments that are under development. In regular font are the ones that are in space already. And you see there's a lot of work that's in development in all disciplines, but especially also in biological and physical sciences. The next slide is a focus on the space station and the geography, if you want, of where these instruments are on the space station. First and foremost, you recognize that there's many disciplines that are represented on the space station. And of course, much of it is on the inside, biological and physical sciences primarily, but there are also some that are on the outside and do unique measurements, whether that's in astrophysics, whether that's in earth science, but also with a future experiment on in heliophysics that are out there. We think of space station as one of the most fruitful, tools for exploration, kind of a platform in which to learn both on the inside and the outside. In low Earth orbit, with the creative work that our human exploration colleagues did, and I really look forward to Kathy Lueders when she, just at the back end of my comments, to really give her view on this. I just think just absolutely incredible, creating that kind of, that ease of access in a level that, frankly, when I did my PhD, we were only dreaming about. Just absolutely incredible. We've taken advantage of that. We're big fans of the space station and beneficiaries of the important infrastructure that human exploration, primarily with the international partners, put together. Speaking of which, next slide, is an indication of that work that happens there. So you basically see, first of all, in the background, NICER data. That's a 22 months record of X-ray data by NASA's NICER instrument, which focuses, of course, on neutron star interiors and composition. Really going after a big puzzle in astrophysics of these important objects that, of course, we don't have an analog in our own solar system. And just important work has been done. By the way, there's also part of that instrument, also a technology demonstration by our tech side of the house, focused on kind of, if you want, the Lord's GPS, these X-ray clocks that are out there and ticking, but very, very, very high accuracy. You see in the front there, Chris Cassidy, and really doing a spacewalk and setting up the Tranquility module for future installation of the NanoRacks airlock. So what I love about this chart, it has all the ingredients. It has, in fact, amazing science. It has, of course, the astronauts are such an important part of this space station. It has the international partners, but it also has the commercial side in NanoRacks that are there. This is a picture from 2020. So these 15 nations that are contributing are just important partners in everything we do. And of course, you recognize that science is truly an international endeavor, and so many of the experiments that we're talking about, whether they're focused on ozone or neutron stars or the upper edge of the atmosphere, are also international in nature. So let's go forward now on the next slide and kind of focus on one of the experiments that I want to talk a little bit about, and that is the Cold Atom Lab. I just showed you on the previous chart the view of the universe, and something we forget sometimes is that there's a universe at the bottom, so to say, as Richard Feynman talked about, kind of the small scales, and Cold Atom Labs are really unlocking that an aspect of that universe as a multi-user facility to study cold atoms in space. It's really a lab, a multi-user facility that is out there with over 100,000 PI experiments that can be performed that, really in the using cooling of sub-nanokelvin temperatures, using atom, lasers, and really these traps that, of course, are there to actually hold up these isotopes that are there that remain to be analyzed, right, and are analyzed by, just to amazing success. There's many investigators team, 5 of them, and there are 3 Nobel laureates. I always tell our team, I'm really excited about having Nobel laureates in the teams, but I'm even more excited is the potential of future Nobel Prizes from work like that. And I just really want to tell you, I believe this is kind of aligned with that amazing work that is there. So next slide shows actually a title page at Nature. If you're a scientist, you may know that, let's see whether you can click one more time. I think there's an animation that should fire. Yeah, go back. Anyway, so imagine beautiful lasers that are going to a central point, which is in fact an image of this incredible incredible experiment that is talked about in this Nature article, which I read with a lot of interest. Really, the cold, ions there that are being analyzed, the isotopes, of course, have unique states of matter. There's Bose-Einstein condensate, which we learned in space as physicists, learned in classes as physicists. And I'm just so excited to see these experiments now going on using multiple isotopes, high and low resolution detection from orthogonal directions, and really the ability to prepare a variety of quantum states and control interactions in ways, frankly, that in which gravity is in the way, to really unlock that world down there and actually do atom interferometry as we go forward, and future geometries. So I just want to tell you how excited I'm about this facility. And of course, next slide, it's not over. There's future steps that we want to take that are, the creation of ultra cold, potassium, and really test out more theoretical predictions and so forth, especially also in collaboration with an experiment that the Germans, DLR, put together to enable the exploration of other states that are currently unknown. So I really think this is at the beginning of this important facility, but an example of something where the space station can really unlock a lot of science in a way that, frankly, we have not seen before. I want to go to the next slide and talk about the advanced combustion via microgravity work that is happening here, and basically really talk to you about work that is set up with multiple studies, with an experiment that began in 2018 with over 1,000 successful flames and ignition, and really uses the ISS in a unique way. Kind of the way I think about combustion. Remember, you're talking to a poorly physicist, but for me, combustion is kind of a multivariable, multi-scale phenomenon which combines deeply chemistry and with interaction fronts and kind of physical environments. And so when you turn on gravity and a thing like that, look at the candle, for example, look at other combustion things in your engine, you have kind of a mix of those variables. And understanding, of course, requires, at the fundamental level, it requires really disentangling the effects that come from gravity and other elements. And so if you look at slide 10, the burning rate emulator that is shown there, and I don't know whether you can actually see that or whether you see a black slide, which is what I see. I sure hope you can see it. Otherwise, I would ask the team to update and actually post these slides to make sure that you can see this kind of what is almost a spherical bubble that is, really in this video, kind of ethane fuel at the constant flow rate, and that is expanding because of it's consuming nearby oxygen and expanding to find more, just like you would guess, kind of in some theoretical model that talks about this. Again, this kind of work, in fact, is enabled by going to space. It's enabled by using microgravity and by the valuable colleagues, our astronauts that actually initiate that, and the organizations that are represented on this call. So what's next for that? Next slide. It's a completion of this series of experiments of gaseous fluids and so forth. A series of experiments examining solid fluids will provide critical data for fire safety and exploration, validate material, and then how it actually burns and how flammable it is going forward. As a former firefighter, I'm deeply acknowledging the importance of this work, and just want to say how much work research overall has made our first responders in this place safer. And I just really look forward to many more discoveries like that. The next slide is kind of the third thing I want to talk about, which is microbial tracking, which is about life up there. And you see here Jack Fisher collecting an environmental sample from the ceiling of the International Space Station in 20 17. Of course, the recognition, and one of really modern recognition, kind of if you look at timescale of medicine, is that life here, kind of our life, kind of the cells with our DNA in it, are not to be seen in isolation, but part of many lives, including many single cell organisms that are part of our bodies. You, of course, know that that microbiome, as we refer to that set, is a critical part of our health. And frankly, many treatments or several treatments are now being released that actually take advantage of knowledge that comes from this. So really recognizing how that works in the environment, next slide, is work that is done by this particular important activity. So it's a 3-year study involving 4 U.S. and international crew volunteers over 4 different ISS increments that really have kind of looked at the inventory of these life species, if you want, over the body. So kind of I said, well, it's a little bit gross to look at all these things, and you think about all the hand washing we do these days. And of course, we recognize, as I said before, this is important work, important part of our life, but especially as we look at the long-term health of our astronauts once they leave low Earth orbit and so forth. It's just a very critical part of this work that is occurring by this important analysis. And so the next slide, of course, shows kind of how some of this analysis is done. I'm sure it reminds you of class that you had sometime in the past. That's what it does for me with this experiment that shows that kind of colonies of fungi grown on a sample that's collected on board the space station. It really helps to analyze the organisms and really help us recognize, of course, that only a small fraction of these organisms grow in a petri dish like this. And so there's a lot of work that remains to be done as we go forward. Last but not least, I want to talk about what is on the next slide, and it's together here with Peggy Whitson, which of course is Veggie, which is really a space garden that is up there. And of course, exciting because of science, but also very useful. And I talked to multiple astronauts about that, about their excitement about having kind of plant life up on the space station of course, just because we all love plants in our apartments. I do, but also because these kind of fresh vegetable salads, whatever they may be, really is deeply appreciated. So if you go to the next slide, slide 16, it focuses, Veg 04A, which is a picture here, focus on the impact and light quality and fertilizer of this leafy crop growth on a 28-day grow out that is, with all the elements all the way to taste acceptability by the crew and the overall health benefit from having plants and fresh foods in space. So the Misuna mustard, which is shown here, is that leafy green crop, was grown for, as I said, 28 days under different light conditions. And so really the goal is for these experiments is to do just what the administrator talked about earlier, is to enable a healthy, in all dimensions of health, transition from our astronauts from low Earth orbit into longer time periods, go to the moon and then to Mars. And I just reminded, just like many of you, I'm following some of these astronauts on Twitter, and Jessica Amir tweeted, "So excited for harvest, and I eat salad every day on Earth. It has been 29 days without one. So let's grow some more salad, friends, and do that for all these reasons." Next slide is, of course, there's future work that remains to be done with that other plants, especially leafy greens for crew consumption, but also other types of plants such as radishes and so forth, to really investigate the underlying mechanisms of plants, which of course in gravity, our plants, the roots know where they're going, and gravity, there's important questions that relate to that have been answered, many of them in front of us. And I just couldn't tell you, and that's the final slide, just want to tell you how excited I am personally and our team is to have our biological and physical science leaders on board with us at headquarters and how excited we are to learn about this work and many other pieces of research that I still have a lot to learn about. Finally, the most important part of, I think, at this critical work, besides the positive impact on human exploration, that a passion we share so deeply with our human exploration friends, is that the combination of biological and physical and sciences with us in the Science Mission Directorate opens new horizons of discovery, new opportunities in ways, frankly, we could not have done before, and exploring with many partners, including commercial partners. We will take advantage of these opportunities and look forward to many more discoveries to come. With that, I'd like to stop and perhaps see whether, before we do Q&A, whether Kathy wants to chime in. Is that the right thing to do, sir?
Thanks, Thomas. No, why don't we go ahead and take a few minutes for questions from you, and then we'll start at 10 minutes before the hour and give Kathy an opportunity to speak. I apologize for the embedded videos. Unfortunately, they won't play on this platform, but as Dr. Zurbuchen indicated, we will post the slides this afternoon so that everyone will be able to watch the videos that we included in the presentation. Just a reminder for everyone, if you do have questions for Dr. Zurbuchen, please post them in the question and answer window at the bottom of the screen. First question, Dr. Z, what future do you see for the new Biological and Physical Sciences Division in Science Mission Directorate?
So I think first of all, kind of the way I always think about an organization coming in, we recognize that important work is already being done at the level of high quality, and kind of a community is captive to this. As we go forward, rule number one is always don't destroy anything. So that is something we're focused on very much. I try to learn very much from our leaders, as do others. In fact, we're working deeply to understand both the cultural differences. Having multiple disciplines, we recognize not every discipline is the same, and that's good. That's not bad. It just is the DNA of it, of these kind of each one of the disciplines. As we look at the future, it really is, I would believe that, and frankly, just want to flag that there's a charge to the academies out for the next decade, which is really how a strategic kind of step looks like in our science disciplines. And I want to ask the community that's on board, both commercial and kind of fundamental RNA communities, to really engage with the academy process, because the strategic guidance we're getting from there, what I believe the future is for us to really recognize that by having biological and physical sciences, especially in the context of astrobiology, combined with all of our sciences, that there's really opportunities that are unmet at this moment in time that remain to be investigated. And our goal, and my goal, is to really enable the ingenuity of the community overall to actually tackle such problems while keeping our relationship with human exploration intact, and actually strengthening that for all the applied work that is so critical for the future of human exploration as we go, as we said, to the moon and beyond.
It's a very exciting future, and opportunities for the community to have input on the way it's shaped. Second question, will there be an opportunity for Gateway to conduct research and technology development as well?
Okay, so I missed that question. You were breaking up. Could you repeat it, please?
Will there be an opportunity for Gateway to also support research and technology development?
So it's an interesting question. Of course, it's interesting because my friend Kathy Lueders is right behind me, who's of course has a lot to do with this, and you want to of course recognize that the Gateway is not the same as the space station in a sense that the space station is inhabited for the last 2 decades without break, right? And therefore, the ability of doing experiments there is is very much tied, in a positive fashion, to the presence of these astronauts. Also recognize that the space station has attach points to experiments on the outside that are really critical. So if I look at the Gateway, so first of all, we already have selected an instrument suite that is going forward, a heliophysics instrument suite that is going forward, and it's looking both at fundamental research in the heliophysics realm, but also teaching us how to integrate kind of a mobile kind of space weather station into the forecasting network, kind of attached to, if you want, a spacecraft with astronauts in it, especially once that moves away from the Sun-Earth line. So on the outside, we're already working with this. We've been doing that from the beginning and do really well. Hermes, by the way, is the name of the experiment on the outside. On the inside, we see opportunities, and I think the team is really excited about these opportunities. But I just want to remind everybody that the facility is a different facility with a different support system, with astronauts there for periods of times, and we don't expect that astronauts are there all the time. So kind of the experiments, of course, need to be adjusted, and these discussions are happening right now and are going forward. But the short answer is yes, but with an asterisk of probably differently.
Thank you. We have time for one more question. An issue that I think is near and dear to all of our colleagues at NASA, and certainly to us at the ISS National Lab. Can you comment on how students from universities can engage with the International Space Station and submit experiments?
So first of all, this is one of the things I'm never going to do is fake that I know all the answers, right? So I recognize that basically much of the breakthrough research that we do in all of science, including biological and physical sciences, involves students and researchers in their early careers. We care about them so much that actually the way we're handling COVID impact is by prioritizing that community, because that capability, that national capability, is so critical for us to support as we go forward. There's multiple mechanisms in all domains to actually support research, from the national lab perspective, perhaps you want to talk about it, but there are mechanisms through PI proposals and otherwise for students to be involved. You should know that we have every desire to integrate biological and physical sciences in support programs that we have in other disciplines, and give it the, just continue to give it emphasis and support students that have great ideas to work often with their advisors in some kind of targeted ways, perhaps even independently through national labs or otherwise, but drive towards breakthrough science that is enabled by this amazing asset.
Thank you so much, Dr. Zurbuchen, for your time today. As I mentioned, we will make sure that we get the slides posted as soon as we can so that everyone's able to see the embedded videos. If you submitted questions and we weren't able to get to them today, we will endeavor to get answers to those and post them on the website as well. Thanks again. Now we'd like to give Kathy Lueders an opportunity to share her insights from her perch as Associate Administrator of Human Exploration Operations and Mission Director. Kathy, are you back with us?
Hello, can you hear me? Just want to make sure. Having IT problems this morning, so.
No, you are loud and clear. Thank you so much for joining us.
Thank you. I'm really maximizing my IT capabilities over this last 5 years, or 5 months. It seems like 5 years sometimes. So 20 years. It's funny because I started in the station program just weeks after 2A flu. And so this really makes me realize how fast 20 years can go. And hopefully both space station, I know the International Space Station's aging well. Hopefully I will be too. But as I really sat and thought about this and thought about what I wanted to talk about today, it really struck me how much both how the ISS really personifies kind of this idea that by us tackling big problems, we drive learning in so many different ways. The ISS every day forces us to solve problems, and therefore is a perfect place for us to have been in the last 20 years as we're preparing really for our next big giant leap. Thomas talked about Gateway and the other areas where we've been building. So just, thinking back through, here are the few things really ISS has taught us. First, people forget, if we were going back to in a time machine to 1992, we forgot that, or before 1992, we forget that in the 60s and 70s, there wasn't any I in space station. It was not an international space station. And so NASA is obviously has a history of doing international collaborations, but embarking on the ISS was really this huge human spaceflight endeavor, and was a big, big step for us in the 90s, right? And through that partnership, over 19 countries have flown their crew members on the ISS. And that provides each of these countries their own little space experience, their own crew experience. Huge, huge benefit for us from an international perspective. Second, ISS has taught us about really how to build, assemble, and integrate in space and operate. So I remember I was in the station program when we flew 2A and we had our first broken piece of hardware. And this will kind of strike you. The first broken piece of hardware was a treadmill slat. And we spent 5 hours trying to figure out and talking about a slat repair. Now, today, that would be a very, very short conversation. And the crew would fix it and we'd move on. I mean, if we think about it, this summer, we were flying a brand new crew vehicle on orbit. And while we had the crew on orbit, we finished our battery change out. Work that in the past, we would have been avoiding while we had that, but we did all this work. And through the integration of the Canadians, the Japanese, and the U.S. operations, we were able to replace all those batteries. Another huge step for us to be able to get ready for our next big leap. These innovations, through learning to fly broke, performing robotic operations, and only using the crew when we have to, is really what's going to enable us to continue to do the science that Thomas was talking about. Plato, whenever I say something like this makes me feel really old, and I was not around when Plato was around, but said that necessity is the mother of invention. And so our need for cargo and crew services to the ISS also spawned a renaissance of spacecraft growth the world has never seen before. I mean, in 1992, if we would have said that by the end of 2020, we would have had 5 cargo vehicles visiting the ISS, 3 commercial cargo vehicles emerging, and then 2 emerging crew vehicles, people would have told us we were crazy. But it's the ISS and that need and having it there and needing to be able to accomplish the science and the research on this platform has enabled this leap forward. Finally, in 2005, the ISS was designated a national lab. And in 2011, the Center for Advancement of Sciences in Space was established. And the other day I asked, I had a multilateral control board, and we saw the chart that says now today over 3,000 investigations have occurred, 4,400 investigators, 108 countries. Amazing what the International Space Station has enabled. And we're not done. The ISS is not done. It's continuing to solve big problems and pushing us forward. We're still figuring out the way, and we will be unlocking the secrets of long duration space flight. This is a critical place for us to continue to figure out how do we make sure that we can fly people in space for a long time. It's also a crucial testing grounds for all the hardware that we're working to support our long-term exploration systems. And all the time we're learning by solving those big problems. So I'm pretty excited to see what ISS has to teach us over the next 10 years. And I'm so grateful to now be the AA of HEO and get to be part of this great team. So thank you for having me. I'm sorry about the IT problems, but I'm I'm really looking forward to hearing all the speakers today and all the teams and continuing to take the learning we do every day on the ISS and provide that to the world. Thank you.
Thank you, Kathy. It truly is an exciting time, and we do appreciate your leadership and your guidance and your ability with Thomas to flex the schedule a little bit here as we can get through the trials and tribulations of virtual world. We do appreciate it.